Now, let us try to understand the graphs of inverse trigonometric functions. So, to draw the graphs of inverse trigonometric functions, the simplest way is to draw a table of values. So, if you are asked to find the graph of y is equal to sine inverse x, you want the graph of y is equal to sine inverse x. First, what I'll do is I'll take the coordinate system. First, what is the domain and range of sine inverse? The domain is -1 to 1 and the range is -π/2 to π/2, right? You have already remembered this. That means the graph extends about x-axis from -1 to +1. And the graph extends along y-axis from -π/2 to +π/2. That is, if I draw a box like this, the graph of y is equal to sine inverse x lies inside this box. So I hope you have understood until this point. Next, if positive numbers goes inside sine inverse, you get angles in the first quadrant, right? So 0 to π/2 corresponds to angles in the first quadrant. 0 to -π/2 corresponds to angles in the fourth quadrant. So if positive numbers goes inside sine inverse, you get values of y in the first quadrant. That means the graph lies in this part. And if you take negative values inside sine inverse, the answers lies in the fourth quadrant. That means the graph of y is equal to sine inverse x lies in this part and this part. The graph does not go into these parts. And to get the shape of the graph, we'll try to draw a table corresponding to x's and y's. So let us take some positive x's, let us take some negative x's. So corresponding to 0, value of sine inverse is 0. Corresponding to half, value is π/6. Corresponding to 1/√2, value is π/4. √3/2, π/3. 1 π/2, and you get the values in the fourth quadrant corresponds to negative values. It is -1/2, -π/6, -1/√2, -π/4, -√3/2, -π/3, -1, -π/2. So let us plot all these points and join them with a smooth curve. You should get the graph of sine inverse x. So 0, 0, that's 1 point. Half, π/6. So if this is π/2, you need to divide this into 3 parts. This is π/6, π/3. So half corresponds to π/6. Next, 1/√2, something like 0.7. So 1/√2 corresponds to π/4. π/4 is somewhere in between them. √3/2, 0.8 something, corresponds to π/3. 1 corresponds to π/2. So if you draw the graph, it looks like this. And you get a similar graph correspond to these values in this part. So you get a graph like this. So this is how the graph of sine inverse x looks like. The domain is -1 to 1 and the range is -π/2 to π/2. Is an increasing function. Sin x is an increasing function. Sin inverse x is also an increasing function. Next, if you want to draw the graph of y is equal to cos inverse x. The domain is -1 to 1. The range is 0 to pi this time. So if you draw the graph extends from -1 to +1 and from 0 to pi. So this time the graph does not go below x-axis because the whole range is positive. Again, if you draw a small box like this, the graph of y is equal to cos inverse x has to lie on this, in this box, and corresponding to positive values of x, the answer lies in the first quadrant. The range lies in the first quadrant. As you get a graph in this box, correspond to negative values of x, the answers are in the second quadrant. As you get a graph in this part. So you get graphs in these two boxes. So how does the graph look like? Cos inverse of 0 is pi by 2. Cos inverse of 1 is 0. Cos inverse of -1 is pi. So just with these three values. So you have a smooth curve joining these values. So how many different options do you have? You can directly join them. That's not the graph. You can join them like this, or you can join them like this. So what is the actual graph looks like? So how I usually remember is the graph of cos inverse x does not look like the graph of cos x. So if you take the graph of cos x, so it looks something like this. From 0 to pi, the graph of cos x looks something like this. So cos inverse x should not look like this. So it cannot go like this. So the graph will look like this. So each time you cannot plot all the values, you cannot draw the table, and always you have to get the graph. So if you want to draw the graph quickly, identify the domain and range, and then identify the boxes where the graph of cos inverse lie, and get some sample points, very easy sample points, and draw the graph. So you should remember that the graph of inverse function should not look like the original function. So this is how the graph of cos inverse x looks like. So even if you draw the table and plot the points and join them with a smooth hand, you get the same graph. Next, let us try to draw the graphs of tan inverse and cot inverse. Y is equal to tan inverse x. So the domain is all real numbers and the range is minus pi by 2 to pi by 2. So if you take the graph, on the x-axis you have to consider the whole real numbers as the domain, and the range is from minus pi by 2 to plus pi by 2. It means if you draw horizontal lines like this, the graph has to lie within this space because the range is only in between minus pi by 2 and pi by 2. And you have an open minus pi by 2 to pi by 2. That means the graph has to asymptotically meet these two lines. Now, if x is positive, the values of angles are in the first quadrant. If x is negative, y is negative. So you have graph here and here. And what is the sample point? Tan inverse of 0 is 0. And it has to asymptotically meet this line and this line. So obviously it cannot go like this. It cannot go in the direction of tan x. So it has to go like this. There is no other option. So here also it has to go like this. Asymptotically it goes to minus pi by 2 and plus pi by 2. So this is how the graph of y is equal to tan inverse x looks like. So if you take the graph of y is equal to cot inverse x, y is equal to cot inverse x. The domain is real numbers and the range is 0 to pi. This time. If you draw the graph, something like this, the domain is all real numbers, the range is 0 to pi, and you have a pi by 2 in between. You draw a horizontal line here. The graph lies in this space, and if you draw a horizontal line at pi by 2 also, you have 4 parts. So in which parts do the graph lie? When x is positive, y is in the first quadrant. When x is negative, y is in the second quadrant. So in these two parts the graph lies. The range is open 0 to pi. That means the graph has to touch 0 and pi asymptotically. So these two lines have to be touched asymptotically. Cot inverse of 0 is pi by 2, passes through this point. It has to touch these two lines asymptotically. So the graph has to look like this. This is how the graph looks like. Tan inverse is an increasing function. Cot inverse is a decreasing function. Tan inverse is an increasing function. Cot inverse is a decreasing function. Next, we'll also look at the remaining two graphs. Now, let us look at the graphs of cosecant inverse x and secant inverse x. Now, for the cosecant inverse x function, the domain is minus infinity to minus 1 and 1 to infinity. That means this part does not come in the domain of cosecant inverse as well as secant inverse. That means there is no graph corresponding to these values of x. Only for these values of x will you have a graph. And as you can see, in the range 0 is absent. That means this curve will never intersect x. This curve will never intersect y is equal to 0. That is the x-axis. So y is equal to 0 corresponds to the x-axis. That means the graph meets x-axis asymptotically. So whatever number is being not there, that is the point where the graph meets asymptotically. So correspond to y is equal to 0, that is x-axis, the curve meets asymptotically. So now, if x is positive, the values of x are positive, then the values of the angles are in the first quadrant, that is, correspond to these values of x, you have y in the first quadrant, that is, you have graph in this part. Correspond to negative values of x, the angles that you get will be negative, that is this part. So you have graph in this part and this part. Now cosecant inverse of 1 correspond to 1, cosecant inverse is pi by 2. Corresponding to minus 1, cosecant inverse is minus pi by 2. And the graph meets x-axis asymptotically. So how should the graph look like? The graph has to look like this. From here, the graph has to look like this. So this is how the graph of cosecant inverse x look like. Similarly, if you go to the graph of secant inverse x, here also between minus 1 and 1, there is no graph. Because this minus 1 to 1 does not come in the domain of secant inverse. Now if you go to the positive values of x, you get values in the first quadrant, that is in this part. For negative values of x, the values of y is in the second quadrant, that is in this part. Now what is the range of the secant inverse x? 0 to pi except pi by 2. 0 to pi except pi by 2. That means the graph of secant inverse x meets y is equal to pi by 2 asymptotically. So now this is the line which is a asymptote to secant inverse x. How does the graph look like? Let us take a sample point. What is secant inverse of 1? Secant inverse of 1 is 0 and secant inverse of minus 1 is pi. So from these points, it has to meet x is equal to pi by 2 asymptotically. So the graph has to look like this. And also here the graph has to look like this. So if you remember how to draw these graphs, it will be very useful in solving certain problems. So all these 6 graphs should be very well remembered.